Our topic is chi-square, which is denoted by x square. The chi-square test is a statistical method that helps determine whether the differences between what we actually observe and what we expected to observe are real or just due to chance. In simple terms, it checks if there is a meaningful relationship between two categorical variables like gender and preferences, or education level and opinion. Education level and opinion. It is called non-parametric test because it doesn't assume that the data follows a normal bell-shaped distribution. This makes it useful when dealing with data that's based on counts or categories rather than measurements. For example, if a researcher wants to check whether boys and girls have different favorite colors, they could use the chi-square test. The test would compare the observed frequencies, how many boys and girls picked each other, with the expected frequencies, what we would expect if there were no differences between genders. If the differences between observed and expected result is large enough, it suggests that there is a significant association between the two variables, meaning gender might actually influence color preferences. If the differences is small, then it is likely just due to random chance and no real relationship exists. Purpose. The main purpose of the chi-square test is to find out whether there is a real relationship or pattern between two categorical variables, or if the difference we see are simply due to chance. It helps researchers to check if they expected to happen actually matches what happened in reality. For example, if a researcher wants to know whether gender influences student preferences for online learning, they can use the chi-square test to compare how many males and females prefer online versus traditional learning. If the test shows a significant result, it means that gender does have an effect on learning preferences. Similarly, if a candy company claims that its packet contains equal number of red, blue, and green candies, the chi-square test can check whether the observed counts, what we actually find in the packet, match with the expected counts, what the company claims. Because of this, the chi-square test is especially useful for analyzing surveys, questionnaires, and opinion polls, where responses are often divided into categories like yes, no, agree, disagree, or male, female. It helps researcher make data-based conclusion instead of relying on assumptions. Types. There are two main types of chi-square tests, and both helps researcher understand relationship or patterns in categorical data, but they are used in slightly different situations. A chi-square goodness of fit test. This test is used when we have one categorical variable and want to see if the data we collected observed frequencies matches what we expected. Expected frequencies, it helps to check how well the observed data fits the expected pattern. For example, a teacher expects students to select subjects like math, English, science, and Urdu equally, but when students actually choose, the number differs. The chi-square goodness of fit test helps find out if the difference happened or by a or if students really prefer certain subjects more than others. Type B is chi-square test of independence. This test is used when we have two categorical variables and we want to see if they are related, dependent, or unrelated, independent. It basically checks whether one variable has an influence on the other. Example, if we want to know whether gender affects preference For online classes, we can apply this test. If the chi-square result is significant, it means gender and preference are connected, dependent. If it is not significant, it means that they are independent. Gender doesn't affect the choice. Formula, the chi-square formula helps us measure how different the observed data O is from the expected data E. X square is equal to sigma O minus E square divided by E. O observed frequency, the actual data you collected or counted, which is given in the question. E is the expected frequency, the number you expected to get if there was no difference or no relationship between variables. In the formula, we can take the difference O minus E for each category, square it so negative don't cancel out, and then divide by E. Finally, we add up all these values sigma to get the chi-square value x square. If the chi-square value is small, it means observed and expected data are quite close, so there is no significant difference. If the chi-square value is large, it means there is a big difference between observed and expected data, suggesting that the result is statistically significant and something real is affecting the outcome, not just chance. Steps in chi-square test: state the hypothesis. Null hypothesis H0, assume there is no relationship between the variables. Any difference is just by chance. Alternative hypothesis H1 assumes that there is a relationship between the variables, meaning the difference is real. Example: H0 gender and learning preference are independent. H1 gender and learning preference are related. Set the level of significance, which is denoted by small a. Usually researchers use 0.05, which is 5%, which means they are willing to accept 5% chance of error in rejecting the null hypothesis. It is the threshold to decide whether results are statistically significant or not. Calculate expected frequencies. The formula is E is equal to row total multiplied by column total divided by grand total. This tells us what we expect to happen if there is no relationship between variables. Apply the chi-square formula. Now we use x square is equal to sigma O minus E square divided by E to calculate the chi-square value using observed O and expected E data. Find the degree of freedom. df is equal to r minus 1 multiplied by c minus 1, where r number of rows and c number of columns. This tells us which value to use from the chi-square table for comparison. Compare the calculated value with the table value. If calculated x square, which is chi-square, if chi-square calculated greater than table value, then reject. H0 means there is a relationship. If chi-square calculated value less than table value, accept. H0 means no relationship, or we fail to reject H0. Example: suppose a researcher want to check whether gender and preference for online classes are related. Out of 100 students, 50 are males and 50 are females. Among males, 30 like online classes and 20 dislike them. Among female, 10 like online classes and 40 dislike them. After calculating, if the chi-square value is greater than the table value, it means gender and preferences for online classes are dependent, otherwise they are independent. A researcher wants to see if gender has any effect on student performance for online classes. In other words, whether these two factors are related or independent. Here is the data: total students 100, 50 males, 50 females. Males 30 like online classes, 20 dislike. Female 10 like online classes, 40 dislikes. Assumptions: data must be in form of frequencies or counts, not percentages. The chi-square test works only with actual numbers of cases or observations, like how many people choose yes or no. You can't use percentage or averages, it must be raw counts. Each observation should belong to only one category. Every person or item should be counted in only one group. For example, if student preference online classes, you count them only once under like, not in both like and dislike. Number three, observations should be independent. Each observation should be separate and unrelated to the others. This means one person's response should not influence another's, and no one should be counted twice. Number four, expected frequencies in each cell should be at least 5. For the chi-square test to give accurate and reliable results, the expected count in each category should be 5 or more than 5. If it's smaller than 5, the results might not be valid or trustworthy. The sample size should be large enough. The test works best when there are enough observations in the sample. A large sample ensures that the test results are more stable, valid, and closer to reality. Hypothesis. In any chi-square test, we start by making two statements, the null hypothesis H0 and the alternative hypothesis H1. These help us decide what we are testing and how to interpret the results. Null hypothesis. This assumes that there is no relationship or difference between the variables. In other words, the variables are independent. One does not affect the other. Example, H0, gender and online classes preference are independent. This means whether a student is male or female has no effect on whether they like online classes or not. Alternative hypothesis H1. This assumes that there is a relationship or difference between the variables. So, the variables are dependent, one may influence or affect the other. Example, H1, gender and online classes preference are related. This means gender does affect the preference for online class. After applying the chi-square formula for comparing the results with the table value, if chi-square calculated value greater than table value, we reject H0, means the variables are related. If the chi-square calculated value less than table value, we accept H0, meaning the variable are independent. Interpretation. Once the chi-square value is calculated, we need to decide what it means, and that is done by comparing it with a table value or p-value. This tells us whether the result is statistically significant or just happened by chance. If p-value less than or is equal to 0.05, this means the probability that the result happened by chance is 5% or less, which is quite small. So we reject the null hypothesis and accept that there is a significant relationship between the variables. If example, if p is equal to 0.03, it means gender and outline and online class preference are related. Gender affects preference. If the p-value is greater than 0.05, this means the difference between observed and expected results is not large enough to be meaningful. It could be easily happen by chance, so we fail to reject H0, meaning there is no significant relationship between the variables. Example, if p is equal to 0.12, it means gender and online class preference are independent. Gender does not affect preference. P value less than or is equal to 0.05, significant relationship, reject H0. P value greater than 0.05, no significant relationship, accept H0. Advantages: very easy to use and interpret. The chi-square test is simple in both calculations and understanding. Once you know the observed and expected values, it is easy to apply the formula and interpret whether a relationship exists or not. Even beginners in statistics can use it confidently. can be applied on categorical data easily. It is specially designed for categorical data like gender, opinion, color, or choices, where responses fall into clear groups or categories instead of numbers or measurements. Works well even if the data is not normally distributed. Unlike many other statistical tests, the chi-square test is non-parametric, meaning it doesn't require the data to follow a normal bell-shaped distribution. This makes it very flexible and widely applicable. Useful for both small and large data sets. Whether you have data from small survey or a large population, the chi-square test can handle both. It is often used in social science, education, and marketing research where sample sizes vary. Helps in testing relationship between variables quickly. The test provides a fast way to check if two variables are related, for example, whether students' performance depends on study methods or whether customer preference depends on gender. Limitations of the chi-square test cannot be used when expected frequencies are very small. The chi-square test becomes unreliable if the expected counts in any cell are too small, usually below 5. If they are below 5, when this happens, the test can give inaccurate or misleading results because small frequencies make the statistical comparison unstable, only suitable for categorical data, not for continuous data. The test is designed only for categorical variables like gender, color, yes, no choices. It cannot be used for continuous data such as height, weight, or age unless those values are first grouped into categories like short, medium, tall. It only tells us it only tells if a relationship exists, not how strong or in which direction it is. The chi-square test can show whether two variables are related or not, but it doesn't measure how strong the relationship is or which way it goes. For example, it can show that gender and online class preference are related, but it won't tell whether males prefer more or female do or by how much. If the sample size is too small, the results may not be reliable. A very small sample size can make the test results unstable or biased because random chance can create large differences even when no real relationship exists. Larger sample give more accurate and dependable chi-square results. So this is the completion of chi-square topic that we have completed here. Thank you so much for watching and listening.